Okay, so E. E is a very special number in mathematics. It came about from a guy named Leonard Euler, who was a very prolific mathematician. He died in his 90s working on trying to solve a proof. Just so you know, that's how prolific he was. The decimal representation of the number E does not terminate or repeat. It is an irrational number that is a constant. So it's called the natural number because it occurs naturally. So where we see this is something called compound growth. So if you remember this, well, we raise that to the power of n. So what happens is that if your n grows indefinitely and goes to infinity, so we just let n go towards infinity, what happens is that this starts approaching this E value. So that is where this natural number comes from. This is something where we compound infinite amount of times. So we call that compounding continuously, which in reality is how things naturally grow. It's like, your baby doesn't grow as in, like it just waits. And then after 3 days, it goes, okay, I will grow now. 3 days later, grows now. It continuously grows. So this is how things grow naturally. That is why it is the natural number, because it's how things are, it's showing something growing continuously. So just quickly with your worksheet, just put in your calculator, see if you have an E button. You should have one somewhere, and do each of these different powers just to see what answers you get. So you're going to be rounding this to the 4th decimal place. Okay. So ideally, if you're getting this to work with your calculator, you should have had E to the 3 is 20.0855 approximately. So remember, these are all approximations. E to the negative 0.23 should be approximately 0.7945. E to the second power is approximately 7.3891. And then e to the first power, well, that's just e, but that's approximately 2.71. So if you have exponents to the base e, this is going to be pretty much just like if you had any other base. Just going to be doing a lot more rounding than if it was 2. But we're seeing that same thing here if I have e to the x and e to the negative x. We're getting that switch. So we're going to have one that's going to be going like this and one that's going to be going like this. But we still see that either way, as long if that exponent is 0, then we are going to cross at 1. It's going to be my y-intercept. So if you look at the graphs, like I said, it's pretty much just like we had before. So as a reminder, we have e to the x, so this means that e is greater than 1. It's an increasing function. If we have e to the negative x, that's the equivalent of just saying I have 1 over e to the x. In that case, 1 over e, that's less than 1, but still greater than 0, so we have a decreasing function. And we still have a horizontal asymptote at y equals 0. There isn't a big difference here. So as an example, we're just going to graph e to the x plus 3, and we're going to use these points at 7, -5, 3, -1, and 0. So really what this is this first one is just doing e to the -7th plus 3, so we just need e to the 4th. And then we have e to the -5 plus 3, so that is just e to the negative, sorry, this is e to the -4th, e to the -2nd. Then we have -3, so -3 plus 3 is just e to the first, or e to the 0, so this one we know is just 1. Then we have e to the -1, so that's -1 plus 3, so that is e to the second power. And then we have 0, so we have e to the 0 plus 3, which is just going to be, sorry, I just lost my place for a second. That's going to be e to the 3rd. All right, so e to the power of negative 4 is approximately 0.018. It's about as far as I'm going to get. E to the negative 2 is approximately 0.135. Then e to the 0 we know is 1. E to the second power is 7.389 approximately. And then to the third power, second, I was just looking here, fourth, then 0 to okay. Yeah, to the third power is going to be 20.086. So we're getting about -7. We're about here, really close to the line. At -5, maybe just a little higher. It's hard to kind of get that one just right. -3, we should be at 1. So we're seeing everything's basically shifting to the left by 3 points, because that should have been here, now it's shifted there. Then we have for, that was -3, -1 is going to be about 7 1/3. Then 0 is going to be way up here, so like double this, 20 and something. It's really hard to scale this sometimes. So it's going to look something like that. Once again, here's kind of a graph of that same line. Okay, so for 11 and 12, you're going to have e to the -1/2 x, and then 1 minus e to the -2x. So like I said, just practice graphing those. And then for that, we just have one other thing to talk about your exponential functions. So because we have this negative in the exponent, is going to cause kind of like this decline that we see here in values. So what we see here is at -2, I was at about, well, e, so it's about 2 2/3 up, a little past that. -1, and it's going to be give us 1 and 649. So this is maybe a little above a half, and then 0 is going to give me 1. Then if I put in 1, it's about a little below 2/3 at a 6.607, and then 2, that's about a little over a third at 0.378. And we know that's supposed to have an asymptotic behavior, so we expect it to kind of level out here. So remember, because that negative exponent, that's essentially saying that this is the same as this. So that's why we're getting that decline, because that negative exponent is just really changed that to 1 over e to the power of +1/2 x. So this one, we're adding on the outside, so I'm expecting that I'm going to have an asymptote at about 1. The question is, am I coming up to the asymptote, or am I coming down, or coming up underneath it, or coming from above it? Once again, we got this negative here, so this is going to cause it to kind of come down like this, but we have this other negative out front, so it's going to cause a reflection where it comes up from underneath. But for -1, what we see here is that we get roughly -6.389 0, we end up with 0 because this is 1 minus 1. If we have 1, then we're getting roughly 0.865. We have 2, we're getting roughly 0.982. And if I have 3, then I'm getting roughly 0.998. So as you see, we're getting closer and closer to that 1 from underneath. -1 is about the negative 6 1/3. Then we cross here at 0, 0. Then at 1, we're getting closer and closer for the next 3 points to this line here. I'm going to use a different color than that pink. So we're getting like that. We're coming up underneath and up to it. So our very last bit for for this E is compounding continuously. So like I said, that E comes about from when we are compounding, like looking at something growing continuously. So we're not, like growing once a month or something like that. That growth is added on continuously over time. So the amount of money A that a principal P will grow after T years at interest rate R in decimal form, compounded continuously, is given by this formula A equals P, and then we have E to the power of RT. So that R ends up in the exponent in this case. So using this formula, we're going to go back to that question where we had $200,000 invested at 2.3% interest. So now we're going to compound continuously and find how much money is in the account after 5 years. Okay, so off to the side, I have what we did with this problem before when we compounded annually, monthly, daily. So now we're compounding continuously. So our formula, it looks like this. So we know that the principal amount, our P, is at 200,000. Then we're going to have E to the power of that interest rate of 0.23 times T. So that is my formula. Now, if I want this for 5 years later, 200,000 E to the 0.23 times 5. So we're going to have 200,000. Then we have E to the power of 0.23 times 5. And what we're going to get is this. Oops. I'm going to go back and do that. It accidentally did not do what I was telling it to do. Let's say I thought that seemed like a little too much money. Okay, I see my mistake here. It's 0.023 as a decimal. I accidentally put my decimal in the wrong place. Okay, there you go. So now that I fixed this, you are going to end up with $224,374.69. So as you see, from compounding daily to compounding continuously, we really gained like $4, less than $4 actually.